Starting in, count it down, the sunset. Here we go. Welcome, ladies and gentlemen. Today we are talking about multiplying and dividing rational expressions. Now, just a distinction in vocabulary. We just finished graphing rational functions. So functions is when I have y equals some expression with x, all right? And we represent those in tables and graphs and stuff like that. Equations would be, right, if I had a rational equation, it would be there'd be an equal sign, first of all, and there'd be all sorts of x's all lying around, right? So it'd be all in terms of a single variable. Today we're not even dealing with functions or equations, where we're dealing with expressions. So the only equal signs are going to be the ones chaining together, right, each of our things as we're simplifying what we have. So we're just like getting like a sentence fragment, mathematically speaking. And we're talking about multiplying and dividing rational expressions. So in order to do that, I want us to start with a recall, flashback here. How do I multiply fractions to begin with? So let's talk about how could you multiply. Let's say I had 2/15 multiplied by, I don't know, 24, let's say, eighths, that'll do. Okay. So, for multiplying fractions, do I need a common denominator? No. What is like the general approach for multiplying fractions? Canceling out, I would say, is the more advanced way and the better way. Yeah. So I'm glad you used that as your go-to method. But if I multiply these, what do I do? What's the general approach? Yeah, perfect, right? I would multiply the tops and I'd multiply the bottoms, right? So I'd multiply 2 times 24, I'd multiply 15 times 8, right? And I just write it as one big fraction, right? So 2 times 24 is what, 48? And then 15 times 8, let's see, 40 plus 80, 120. And this is my answer. Now it's written as a single fraction. I can simplify that now, through some canceling out method. I think 4s are going to go into these a lot. Let's see what I can do. Oh, 12 will go into it. 12 goes into 48 4 times, into 120 10 times. And then 2 goes into that. So 2/5 is my answer. All right, so for multiplying, you can just multiply across is what we did. I always put, I'm always never sure, always never, yep, whether there's 2 C's in across. Sometimes that happens with words like tomorrow. I know that there's double letters in there, and I'm like, I think it's double R, but I'll just be like, I'm just going to double everything. And I'll just be like, at least I know I'm right for the double letter one. And that's what I'll do. So I do the same thing with a cross because I know it ends with a double S. There we go. I'm going to leave the double C there. And actually, it almost looks like an O nestled up against that R there. So that's Acoros. Yeah, there you go. That's fine. So that's one strategy you could do. The other is you could cancel out, is what our student suggested. Which I might call this cross-canceling, is another way you can think about it, where I'm going to realize that I can start, actually imagine it in this state right here. I can, now that these are all together, I could start canceling stuff out, blah, blah, and cancel out what I can, right? But I can actually start canceling out before I even multiply them. And the reason I like this strategy, multiplying gives me big numbers, all right? And when we got to 48 over 120, I'm guessing not all of us knew how to divide that. I didn't get it on my first shot, right? I had to break it down twice before I found the most reduced fraction. So multiplying gives us really big numbers. Chances are we might not be awesome at multiplying all of those numbers if they're big. And then even worse, we're probably less off as far as dividing those numbers once they're big. So the nice thing about canceling first is canceling gives me smaller numbers. So if I cancel and then multiply, I'll have smaller numbers to work with, and chances are I could do more of the math in my head. So 2 and 8, I want to point out 2 goes into 2 once and into 8 4 times. And then 24 and 15, does anything go into both of those? 3, yeah, 3 goes into 15 5 times and into 24 8 times. And it turns out I can actually, in this case, because 24 eighths wasn't fully reduced itself to begin with, I can actually reduce even a little bit further at 8 and 4 here. I could multiply across now and then reduce, or better yet, let's just cancel right now. 4 goes into 4 once and into 8 twice. And now if I take these values, I've got 1 times 2 is 2, and 5 times 1 is 5, and bam, there's my answer right there. So this method is called cross-canceling. Oh, I'm going to double L it. I don't think it's supposed to have double L. That's all right. Who cares? This lesson has nothing. Notice the title of this lesson has nothing to do with spelling words with 2 of the same letter side by side. It's not the title. So go to another YouTube video, friends. Are there YouTube videos about spelling? I don't know. I imagine there's at least spelling bee YouTube videos. Huh. It's interesting. Well, anyways, so let's actually get into the math we're talking about. Actually, I think we've already done, this is probably another recall, but why not? What if I've got like 2x squared over, I don't know, 3y, no y's. We'll skip the y's. Over 3x to the 5th multiplied by, what if I've got 12x to the 7th over, I don't know, x to the 3rd or something like that. Now, I think we've had problems kind of like this back in the days of properties of exponents, but these are rational expressions, right? They've got little polynomials in them and dividing them, so yeah, that's rational. So I can, in this case, if I wanted, I could multiply across, right? 2x squared times 12x to the 7th would be 24x to the, let's see, do I add, multiply, subtract, divide? What do I do with these exponents? I add them, right? Bam. And then 3x to the 5th times 3x cubed, I would get 3x to the 8th. And then I could cancel now if I wanted. 3 goes into 3 once and into 24 8 times. And I would subtract the smaller exponent from the larger. All right, so it looks like my answer would be 8x to the 1st, right? Or just 8x would be my answer. Now the same problem done using my cross-canceling techniques. I could have started canceling stuff out right off the bat. I could have realized 3 goes into 3 once and into 12 4 times. I could have, well, depending on how I did things, I could say, oh, I could subtract 2 from the 5 and the 3 from the 7. There's all sorts of ways I could do this. So I would have, let's see, 2 times 4 is 8. Let's see. I guess I'm doing a bunch of things here. 5 minus 2 is x to the 3rd. Kind of multiplying and canceling at the same time. And 7 minus 3 is x to the 4th. Right? But there's all sorts of ways I could do this. And then I could subtract the smaller exponent from the larger here, and I'd get the same answer of 8x, right? So, really, there's a lot of different options for doing these. Now, these were all monomials within my numerators and denominators here. What if that was not the case? So now we're actually going to see our first new kind of problem. So what if I wanted to simplify? And what if I had this? Should I just do a straight simplifying one first? Nah, maybe. What if I've got 4x to the 2nd minus, and let's say I've got 2x all over, let's say I've got 2x minus 1. So I'm not yet multiplying here. This is just a single thing, and I'm trying to simplify it, I guess, would be my instructions if I had them. And I just want to... You guys are going to be super tempted to cancel stuff out right now. And we can't yet. All right? But I'm glad that your eyes are already like thinking about that, but you're going to have to like restrain yourself until the very end. Some people might be like, oh, 2 x's, those can cancel. Or they might be like, oh, this 2 could cancel with that 4, this x could cancel with that, and or my son watches like this little crayon coloring show on Netflix, and this little eraser dude comes out and he's like, and like he like erases the color that the crayon colored wrong. That's what it reminds me of. People can't do that. Can't do that. However, if I had this written as the product of things, right? If I had it written as like things being multiplied, if I had them factored, then I could cancel out factors, all right? But I can't cancel out like that. So this numerator, I can actually yoink out a 2x. I don't know if anyone spotted that. So if I yoink out a 2x, what would I get on the inside of the parentheses? 2x minus 1 over 2x minus 1, right? And behold, now that I've got this all written as like multiplication, this denominator technically has parentheses around it because this vinculum is a type of grouping symbol, right? This fraction bar is saying this whole thing is one piece. And now that I've got it like this, I can cancel out a 2x minus 1 with a 2x minus 1. Okay? So you can cancel out factors with factors, but you can't cancel out terms with terms. That would be super illegal. And actually, I think that's what I always call it. I say super illegal. That's what I say. So I know it probably feels subtle to you now, all right? But you can't cancel anything out until it's all written as multiplication, all right? And that's technically even what we had here. There was no addition or subtraction going on here at all. So just be aware of that. So let's see. Let's do an example where we kind of combine our skills here. What if I want to multiply? And by default, we should always have our answers in simplest form. So what if I want to multiply this? What if I've got x squared minus 9 over x plus 3? Okay, whatever. It's too late. It's done. Done and done. And what if I've got x squared plus 5x plus 6 all over, and let's throw in a meh. How about an x squared minus 6x plus 9? So for those of you who are not fans of factoring, or perhaps not masters of factoring, I'd like to point out that like a single multiplication problem could have as many as 4 separate factoring problems all built into one. Craziness. So I apologize on that regard, but we are going to be so good at factoring here, people. It's going to be good. It's going to be good. So my general strategy is, all right, first of all, I want to point out, super illegal to do this. I can't go, yeah, and then 3 goes into 3 once, and then 9 3 times. No, super illegal, guys. Come on. Let's try to factor everything I can. All right? Does anyone know how to factor x squared minus 9? Someone spotted the difference of squares pattern earlier. X plus 3, x minus 3. I like it. Does anyone know how to factor this denominator? You don't. It's not factorable. That was a trick question. Man, you guys are good. Does anyone know how to factor this guy? Now, fortunately, I didn't give us any AC method problems here, but that can happen. I'm sorry. Let's see. Well, I would find the factors of 6, which are 1 and 6, 2 and 3, and which of those add to be 5, right? Now, if this was a minus 6, then the 1 and 6 would have worked. But I think it's going to be the x with a 2, x with a 3, right? And what are their signs going to be? Anybody? Positive, positive. And this last one here actually is a pattern, but if we didn't notice it, I would find the factors of 9 are 1 and 9, 3 and 3, and which of those add to be 6? 3 and 3. So I'm going to end up with an x minus 3 and an x minus 3. Or if I realize the pattern, it would be x minus 3 all squared. So I want to point out here now, everything is now written in terms of multiplication. Even this, I could put parentheses around that if you wanted. And now this is the fun part. All right, this is the fun part. I can now like go crazy fruit ninja on this. Have you guys ever seen the movie Good Will Hunting? There's a scene where like his math professor dude is like sitting in like the front desk, and Goodwill, I think is his name, good old Will, and he's like on the board doing a math problem, and he gets to this point, and then the math professor just like nods and like stands up, and then they both grab pieces of chalk and they're just like and like canceling out, and it's like, oh yeah, fruit ninja. Like they're just having a blast. It's the best part of the problem because it's like I can just cancel stuff out left and right. This is great, and that's where we're at. This is right where we're at. I mean, the problem we just did isn't as complicated as the one in that movie, but I'm just saying, like we can now like cancel stuff out. What does anyone see anything that can cancel? Anybody? X plus 3 and x plus 3, those can cancel. I want to point out, notice I didn't do this and this. Can't do that. It's going to be on different levels there. Does anyone notice anything else that can cancel? Perfect, right? She said one of them, right? I could think of this as an exponent of 1 that I'm subtracting from the exponent of 2 if you wanted, leaving 1 left over. So let's see. So my final answer, I guess I can put some equal signs in there. It looks like I've got x plus 2 times x plus 3 all over 1x minus 3 is hanging out. And if I wanted, I could put parentheses around it, although I don't have to, since it's the only expression in the denominator. And if you wanted, you could multiply out the top again, but forget it. I'd prefer you leave these factored. I find that more valuable information can be gathered from them when they're in that state. So yeah, so there's that. Good stuff. So the key is factor everything. Factor everything. Why is it skipping a letter there? Everything. And then step 2 would be like your cancel and multiply, or multiply and cancel, whichever you want to do. Cancel / mult, right? Something like that. This is the general idea. But don't try to cancel things out until it's factored, because it'll be super illegal. It will not be cool. Not be cool at all. Let's see. And so there's multiplication. How about division? Maybe I'll start with a quick little recall. I know we're running low on time here, but it'll be good. Recall and then one last example will be awesome. Awesome sauce. So, recall. What if, this was a problem that showed up the other day. Something like this. What if I have 2/3 x equals 1/5? How would you solve that for x? 2/3 is being multiplied by that. What would you do to undo both sides? Ooh, perfect, right? That is our new fixed, the most efficient way to do it. Technically, right, to undo multiplication, though, you would say, oh, divide both sides by 2/3. But no one would say that, right? Because that's, gross. How do I do that math? I don't know. But instead of dividing by 2/3, we have a different strategy, right? You said we multiply by the reciprocal. So multiply both sides by 3/2. And this actually isn't that bad. So I'd get x equals, because, here we go. Here's some Goodwill Hunting. That all cancels out. So x is by itself. right? Like if they were in some sort of like fight to the death, free-for-all arena, like all of those people died, and then X was just like, I'm the boss. And now we just multiply across or cross cancel. There's nothing to cancel though. 1 times 3 is 3, and 5 times 2 is 10. And there's my answer, which is way easier than 1/5 divided by 2/3. I don't know the answer to that, right? But this I do. So the idea was multiply by recip. Question, comment, observation? Stretching? It's all right. It's Monday morning. Now the internet knows what time it is. Oh no. They're going to hunt us down. They also know, They know the name of the YouTube channel, Twin Valley Math. They might be able to figure out where we are and when we are. A time traveler might, like they're narrowing down, they could find us in this very moment. Well, if they do, I guess they'd probably try to stop me from doing this next problem. Let's see if they show up. That'd be pretty neat. So let's do this. How about I've got x squared minus 1 over... Let's do x squared plus 4x and minus 12. I was worried there for a minute. Yeah. And I'm dividing by another fraction. What if I'm dividing by, let's just make this x plus 1 over, and let's say I've got, x squared minus 16. How about? This will be our last problem. We are going to be awesome. So the general strategy, I'm not going to try to divide a fraction by a fraction. Instead, I'm going to multiply by the reciprocal. All right, so I'm going to, in general here, in a moment, I'm going to change this to the multiplication by the reciprocal of this guy, right? Where else? Just switcheroo those things, right? But before I do that, I might as well try to do 2 things at once here, because I don't feel like writing all of those down again, right? And then just being like, oh, now I want to factor those, right? Because that would be my very next step. So let's factor it and flip and multiply. Actually, I remember a math teacher I had in high school, she would just say, just flip and multiply. And it sounded like she was like yelling at us, like flipping as in like some alternative swear word. Like, just flip and multiply, guys. And I was like, what did I do wrong? Like, what? Like, okay. Like, that's what it sounded like. So we're just going to flip and multiply here. It's going to be great. So I'm going to factor simultaneously here. X squared minus 1. All our factor skills are going to be coming into play here. What does that factor to be? Yeah, you guys are going to be so good at noticing difference of squares patterns. It's going to be amazing. Let's see. This guy right here, I'd find the factors of 12, 1 and 12, 2 and 3, 3 and 6, or no, 4, 3 and 4. Nope, 2 and 6, 3 and 4. There we go. I got there eventually. And which of those subtract to be 4? Two and 6, yeah. So I'll have an x with a 2 and x with a 6. Yeah, that wasn't the problem I thought it was when I wrote it, but that's okay. It'll all work out. And what are their signs going to be? Minus plus, the more influential had to be positive, being the 6, because they had to be a positive term. And let's see, I flipped this, so x plus 1 is not factorable, but now it's downstairs. And x squared minus 16, is that factor? Yeah, that's a difference of squares pattern right there as well. And I wish I had more stuff for us to cancel out, but sadly I didn't plan the problem that well. So let's see, does anything cancel? Yeah, x plus 1 with this entire x plus 1, all right? So you can put parentheses around that because it was the only thing in that denominator. And then my answer is just the product of all of these things, right? So equals, it'll be x minus 1 times x plus 4 times x minus 4 all over x minus 2 times x plus 6. And if more stuff canceled out, it would have, and it would have been cooler, but alas, that was it. So that's the idea, is division problems can be rewritten as multiplication problems without too much difficulty. You just flip and multiply, guys, seriously. Come on. Alright, so we're good there. Let's see if we have time for some compañeros trabajamos. I don't know if that made any sense. Close enough.